Hi, my name's Mark Weems-Holden. I'm the UK National Project Manager for F1 in Schools. We're going to show you how you can inspire your pupils through a STEM project with a difference.
So let's take a look at what we're going to cover through this workshop. First of all, how to get involved in F1 in Schools, what's it all about and what does it take to compete? How you can use the Denford Primary STEM project as an ideal starting point to prepare your pupils for the competition, doing that as an in-class activity. How you can teach D&T as a kind of core subject, but in a relevant, exciting way so that it's something students look forward to. Building on from that, how you can then embed STEM in a way that makes pupils understand the link between the subjects into something really tangible that makes sense to them. How you can then plan a series of lessons to create a cross-curricular project through not just the primary STEM project, but also the primary class competition. Pick up a few handy tips and tricks for teaching design work especially, and then know where to find some additional resources to help you and your pupils succeed in all of the above. If you want to play along and do the activities as we go through the course, you might want to get yourself an IsoSketch 3D drawing tool, a pencil, a pair of scissors, and access to the PDFs that we'll mention throughout the course to print off and do as we go through. So let's start with the basics. What is F1 in Schools? Well, it's a journey that could take the students from 6 all the way to 19 years old through primary class, entry class, development and then professional class as they work through secondary school and colleges. They can form teams of 3 to 6 members and take on job roles such as project manager, design engineer, marketing manager, manufacturing engineer, graphic designer, or really anything that they want. And it could be that their dream job is one that they can think up themselves. At its heart, F1 in Schools is a process. So like a design project or any other project, you research, design, analyse, make, test and race, all sort of encompassed around the principles of STEM. So with the scientific research going on at the beginning, you've got all the design skills and the analytical phase where you're working out which is the best idea, which is the one that we're going to go with. The prototyping and making stage, the actual testing of those prototypes in whatever way that the students can manage, and then ultimately the racing of them, whether that's in school, in a local competition, or at one of our F1 in Schools official events. Well, that all sounds great, but how do we actually get involved? So what's the first step? So that's where the Denford Primary STEM project comes in. This is a fully resourced project in a box with all the equipment you'd need to run a mini F1 in Schools project within school. Your teams are going to research, design and make a fully working little car, which is going to be powered by a compressed air launcher powered by a bike pump. And they're going to race down a little rollout racetrack which you can put in the school hall, measuring 10 metres. The whole point of this is to use science and maths to work out how to go faster, bringing in aerodynamic principles, while at the same time employing team jobs, so project manager, engineer, designer, etc., to give the students a sense of ownership over what they're doing, but also find what they might be good at, what they might enjoy the most. The whole point is to overcome the problem of how do we go as fast as possible from point A to point B, and working together creatively. Then this can become the start of an entry into an F1 in Schools primary class competition where the students would need to take what they've done in school, modify it to become a race car and turn up at one of our regional final events ready to run in the primary class. Most importantly of all this though is to have tons of fun all the way along this journey so that none of the learning is lost on them. Everything counts and everything is enjoyable. Let's take a quick look then at the Primary STEM project in action. Now let's take a look at how you can embed science into the project. Well, the first thing to say is that the science of speed is something that companies around the world spend probably millions, if not billions of pounds every year trying to research. How to make their objects, their products more efficient within the same parameters, so travelling through the air or through water more efficiently and faster. So that's kind of the key fundamentals of this project and how you can address science. Is let's think about how forces and the shape of our object can mesh together and create the fastest car possible. What design features do the students want, and whether those features are actually going to make it faster or slower. Let's not forget that wings, while wings are mandated in some forms of motorsport, they're not actually faster all the time. So there's some misconceptions to be addressed. Things that might cause the car to go slower, so thinking about factors like weight, factors like temperature, humidity, and then having a think about what other factors such as air resistance and gravity and air pressure can do to the car itself. A nice activity that you can do to highlight the science behind the project is the Paper Aeroplane Challenge PDF. So if you want to download and print that off, you can use this with your students to get 2 pieces of A4 paper, starting with the same size and same weight of material, turn one into a scrunched up ball of paper, for example, and the other one into a nice neatly folded plane. Drop them from the same height and see which one drops to the ground first. The whole point being, ideally, that you can highlight how the shape of something affects its aerodynamic properties and therefore its speed through the air. Let's get creative now and see how we can inspire your pupils through design and sketching in the project. One of the coolest tricks you can do as a teacher with this project is by using the IsoSketch 3D drawing tool to show your pupils that they can all draw in 3D with a little bit of help and the right equipment. So by starting off with something like the IsoSketch, creating some basic 3D shapes at first, you can show quickly how they can develop that into an understanding of 3D design to then design the chassis and also the body for their race car. Being able to challenge the whole I can't draw mindset is going to be vital to opening up the minds of your pupils here to experiment with designs for wings, body shapes, aerodynamic surfaces. So kick off with IsoSketch, get them to think about basic 3D shapes, a cube, and turning it into a nice dice shape just to build some confidence, and move them on with video tutorials that we've got on the website, showing them how to design a chassis, how to then sketch a body over the top of it. You've got to start somewhere, but this is a real nice standard to aim for. A cool trick you can do is to do what we call iterative design, so iterations of a design, i.e. versions which are very slightly different, but every time a little bit better, so improved on the previous version. A cool trick to use is use tracing paper, or really thin paper at least, and actually draw one design first, but then just trace over the top of it for subsequent versions. So rather than going back to the start, drawing an idea again, which takes lots of time, just start from that first sketch, trace over it, and make the changes you want to see, just like a real designer would do. If you want to play along, then the activity here is to have a go at drawing the chassis of your race car yourself. So using an IsoSketch drawing tool, if you've got one, you can link to the video which is on our YouTube channel. Have a go designing the chassis first, measuring all the angles out, using the tool, and then after that, have a crack at doing a design for a cool aerodynamic body over the top of it. That version that you create could be your exemplar that you show your students. So having a go at this yourself gives you a bit of experience with drawing the shapes and using the tool, and then gives you a bit of a chance to have some ideas about how the body could be designed and how the students could go about doing it. Let's just take a quick look then at those IsoSketch drawing tutorials. Next up, let's have a look at what manufacturing methods we can explore. One of the key principles of the manufacturing process has got to be options. Options for methods of creating, first of all, the designs, whether it's in CAD packages or whether it's by hand and sketching things, whether it's by making sketch models and prototyping that way. To be able to experiment with ideas, both in 2D and 3D. Because that's how you'll get across to the pupils that it's okay to change your idea. It's not a case that you have to decide on your final idea right from the start. That development is good, it's a healthy thing to do. So being able to keep making changes to a paper net or an idea on screen or even on paper to just develop the idea as the project grows. Use free software. Things like Tinkercad is a great free resource from Autodesk. to help you show the pupils how to visualize a design on a computer screen in 3D with all the benefits of computer-aided design. So easy to edit, easy to make changes to, etc. This is a really nice little point in a journey where they could learn how to do that. Otherwise, you could sort of go on without it, but it's a nice point in the journey to be able to show them how 3D CAD on screen can be used. The whole point then is to be flexible in how to manufacture the car. So you can create the custom car and custom body from card yourself. You can do you could use CAD packages, and you could use CAM machinery, so a cutter plotter, for example, to cut the design out for you. Or just use freehand skills and make it about, you know, being accurate and measuring carefully and bring numeracy in that way. Then the process is very much a sort of engineering-led, following a process, thinking about what order pieces go together in what way, assembling that 2D net into the 3D shape, and then the context being that we're doing this task to create a finished race car, one that is going to go as fast as possible from point A to point B because of the way that we've carefully and accurately designed, made, and assembled it. So with manufacturing and accuracy now in mind, it's time for an activity. So the ChassisNet PDF is another download that you can print off and use yourself. We've not done the easy work for you here because it's not pre-cut out, but that's something that you can have a go at yourself. These would be pre-printed and pre-stamped, so the actual cutting task isn't there for the students, thankfully. But in terms of assembling it, that's something you can have a go at yourself. Once you've done it, then it's a nice chance to have a go at experimenting using just paper or thin card to have a go at adding some aerodynamic surfaces, so, you know, different styles of wing and side pod and front wings, back wings, just to start making this thing look like a race car and give some talking points as to whether we think these are fast features or things that are going to slow the car down. Now let's take a look at how to assemble the car's chassis. It might look great, but does it work? Let's look at testing. One of the most difficult things to ever get right with a design project is proving that something works. Proving that an object you've designed has its desired impact on life, on performance, on people, whatever it is it's designed to do. So with the project like this, the actual testing process is really straightforward and very accessible. Simply put, does your car go quickly from A to B? And it's that makes the link between what you thought was going to happen, what you hoped you would achieve, and what actually does. And it could be that it throws up some really interesting conversations about what they thought was going to be quick and what they actually found in the end to be quite slow. So another benefit of the Primary STEM project is that you can do all this within school. You don't need any external equipment or external agencies. You've got the whole thing in the box. So by rolling out the little racetrack and using the air pump to test the cars, you've got a direct, real-life comparison between a couple of designs perhaps, testing which ones are going to be the faster ones, doing a few variants and looking at which ones go faster, which ones are more strong when they reach the end of the track, working out whether strength or speed is going to be the key. And this is a classic conundrum in motorsport and performance in general, even aviation, for example, of how fast something is and how efficient it is compared to how strong it is and how safe it is. So these are all really good little learning topics that you can bring into testing while doing it visually and properly in front of the pupils, rather than having to hypothetically test your ideas. An activity idea for testing without a racetrack is to make a little wind tunnel. So you could do this by using something like a hairdryer or even just a cold air fan, and attaching some little bits of string or some bits of plastic streamer, something really lightweight and fine, but that you can see visually, attaching that to the car and then blowing an airflow across the shape. Now, the idea there is that you can see where bits of turbulence, or basically the air gets churned around by an unsmooth surface. This is the sort of thing that companies spend millions on in wind tunnels to look for where air is disturbed running over a shape, especially in motorsport with Formula One teams looking to try and maximise their aerodynamics. Something like this that can be done visually, recorded on maybe a phone and then viewed back in slow motion, can give the students another little window into what's happening as air is travelling over their car. So have a go at that maybe with some bits of craft materials in school and see if the students can get some more testing results out of that as well as just track testing. Possibly the biggest hurdle to starting a new project? Lesson planning and resourcing. Let's take a look. Naturally, teachers will always want to adjust resources and lesson plans and PowerPoints to be consistent with their own style so that they're in keeping with everything else they teach. Now, with that in mind, an awful lot of the planning is not shared with the students. The lesson plans, the full sort of teacher directory back end, if you like, of the project, that is all done and that's ready to go. So there are 6 units of work, including lesson plans themselves, worksheets which have been generated, all branded, and this is all mapped to the national curriculum. So the units of work relate directly to the areas of this project, but in line with the national curriculum in terms of STEM in primary schools. There's a huge element of team building and teamwork in this, because that is going to be at the core of what the students really get out of this, working in a team with a team dynamic and being able to sort of share the work with each other, but also specialise in certain areas themselves. There are tons of activity sheets ready to go, print out, distribute them. There's all sorts of little conversation topics on there that you can pick out. And really, the competition itself is the sort of end goal. It's the reason that the teamwork should naturally blossom, because they're all focusing on this end point, which is when they get to put to the test all the work they've done so far. Because it's teamwork as well, you can kind of encourage independent learning to an extent by allowing the teams to work at their own pace with the resources that you've developed, that we've shared, and then bring all the ideas together as a class to see who's achieved what in the time. These are all available on the website, they're all available with the project, and essentially they're there to take the real headache work out of starting this and having to plan it from the ground up. So do use the resources. Maybe have a look on the Primary STEM Project website and download some of the example resources which are there that just give you a bit of a window into what the resources look like and how you could use them. If at the end of all this you and the pupils are still hungry for more, you can modify your Primary STEM Project cars to become F1 in Schools competition primary class cars. So let's have a quick look at how you'd modify the cars using the Ready to Race pack to turn them into a competition entry. F1 in Schools primary class pitches teams from different schools against each other in the ultimate test. F1 in Schools primary class is the first step on the F1 in Schools competition ladder. The idea here is that you've started in class with the Denford Primary STEM project and you're going to turn your car, your classroom project, into an official F1 in Schools primary class race car. So that brings with it quite a lot of pressure that the teams will have to get, first of all, excited about and then work out a plan for. They have to install what's called a Ready to Race pack of safety add-ons, which mean that the car can run on a 20-metre elevated racetrack powered by a 4-gram compressed air power pack. This is all about them competing against other schools now and testing themselves against competition that they don't know, so being as well prepared as they possibly can be. This element of the project is really where you start to see the best out of the students, because they really have to start working to really tight deadlines. The competition date is set, and work with each other to make sure that the work gets done. The event itself is a massive test. It's a test of teamwork, of obviously team spirit, work ethic, and keeping it together on the day. Launching the car down the track is one thing, and obviously talking to the judges is another thing. They don't have to produce the work again. They don't have to start from the scratch. They can take everything they've done and turn it into a portfolio of their design work, going from research all the way through development into final designs. They can show the judges that and rehearse a team presentation to wow the judges with how well they communicate as a team, their whole journey, and sort of really jazz that up as a full, energetic team performance. Again, the competition element is where we see a difference in the students, because all of a sudden you're taking them out of the comfort zone of being in their classroom with just yourself, the teacher, and putting them in front of people they don't know, people they've never seen before, but actually people that are very similar to them. So the reaction you sometimes see from them is one immediately of, oh wow, what are we going to do here? But then immediately going, right, we understand what we're doing here because we're just part of this competition and we're here to win. So it's a fantastic way to get a different element of learning into this project, where you're seeing a different reaction because of a different set of scenarios. The very best regional teams go on to the UK National Finals, which itself is an incredible launchpad for the students, not just because they'll be in a live event which is filmed and broadcast, but also because it could be that first step on their way to a dream career in STEM.
Well, I hope you found that interesting and useful. If you want to find out more about the Primary STEM project and to purchase or to download the links that we mentioned, click here. If you want to find out more about F1 in Schools primary class and how to enter the competition, click here, and we'll hope to see you soon.